In this video, I want to do a couple of examples of finding the limit of constant functions and finding limits using direct substitution. Here we're asked to find the limit as x approaches 6 of the constant function 4. The graph of the constant function 4 is a horizontal line that goes through 4 on the y-axis. So it's a horizontal line at a height of 4. Let's think about the left and right side limits. As we approach 6 from the left, the height zeroes in on 4. And as we approach 6 from the right, the height zeroes in on 4 as well. So we know the limit of this exists, and if the left-sided limit is 4 and the right-sided limit is 4, then that means that the limit is 4. And that holds true for any constant function. Anytime we're trying to find the limit of a constant function, the limit is just the function itself. So that's pretty simple, right? The limit of any constant function is just that constant. And in many cases, we can use what's called direct substitution to find limits. Here we're asked to find the limit of t squared plus 5t plus 7 as t approaches negative 2. And this limit technique should be our default technique for any limit that we're trying to evaluate. In other words, this should be the first strategy that we try in all cases of trying to find a limit. Direct substitution. Direct substitution involves substituting the value that our variable is approaching, in this case negative 2, and substituting negative 2 directly into the function, in this case for t. So that would give us negative 2 quantity squared plus 5 times negative 2 plus 7, which gives us 1. So the value of this limit is 1. And again, this technique, direct substitution, should be our first and foremost go-to anytime we're trying to evaluate a limit. Now we'll see in some later videos where direct substitution doesn't always work and we have to use other techniques, but I'll cover those other techniques in future videos. So if direct substitution gives us a value for our limit, we're going to use it every time. Let's find the limit of 3p over the square root of 4p plus 1 minus 1 as p approaches 2. Again, the first technique we're always going to try is direct substitution. If direct substitution gives us a valid value for our limit, then that's it. We're done. So let's substitute 2 into our function. That gives us 6 over the square root of 8 plus 1, which is 9, minus 1, which gives us 6 over 3 minus 1, which is 3. So the limit of this function as p approaches 2 is 3 using direct substitution.